All right, I'm sorry I didn't get through the notes in class. I'm going to make these videos this video to kind of walk you through the notes if you want to watch it. All right, so I want to graph this polynomial, so I need to factor it. I'm going to first factor out a -2. If I take a -2 out of GCF, that gives me x to the third minus 2x squared minus 4x plus 8. Now I'm going to factor a 4-term polynomial by grouping. -2, nice big bracket. I'm going to take an x squared out of the first two, leaving me with an x minus 2. -4 out of the second two, leaving me with an x minus 2. Which leaves me with a -2, and then take an x minus 2 out of those two terms. X squared minus 4. Oh my goodness, one more step. I'm going to erase it here to maximize my space. Sorry, I didn't leave more space. Apologies all around today. -2, x. So this factors into x plus 2, x minus 2. So that's an x plus 2, and then an x minus 2, and a second x minus 2. I'm circling like that's my answer, but of course it's not. Okay? So now I need to find the end behavior, the x-intercepts, the y-intercepts, and graph it. X-intercepts are the easiest because it's in factored form now. So x equals -2 and +2. And the -2 has a multiplicity of 1, and the +2 has a multiplicity of 2. It's got a power there. End behavior, as x approaches infinity, your y approaches, so plug into your lead term, plug in a positive infinity, or this idea of a big number. So positive infinity to the third is positive times a negative. Same thing for a negative. Gives you a negative times a negative is a positive. Y-intercept, I guess I should have said this is the easiest one. Y-intercept, plug in x equals 0. These all go away, so you just get -16. So there we go. There's the stuff. Now you should be able to graph it. Sketch a graph. So -2 to 2, I'm going to go up to about 4. 1, it helps. It really does help to spread these out. 1, 2, 3, 4. You want lots of room to get all the curvature that you need here. Do not scale the y-axis. Write down your end behavior. As x gets big, y gets small. As x gets small, y gets big. Plot your x-intercepts. Boom, boom. And now let's graph it. So the -2 has got a single multiplicity, so you know it's going to just kind of go straight through. Is it like this or is it like this? Well, look at where you're starting. I'm starting from up here. The function is going to come from up here. Don't start it over here. It's got to come through here, and it's going to go straight through because it's a single multiplicity. So just kind of like that. Now it's going to be coming from down here, and it's going to come up to this one. And this one's got a double multiplicity, so it's going to look like a parabola. So if it's coming from down here, it's going to look like a parabola. So what I'd like to do is, instead of coming from here and doing this, get that parabola right here. And in fact, this is the end of it right here, so that's kind of the end. Then here, now I got to somehow connect these two pieces. Now it's not going to be minimized here, and this isn't super important, but do you see how this one is flat coming over here? So it's kind of more to the left, and this is just coming straight through. So that means that minimum is going to be over here somewhere. It's going to be on this side. Whatever. It's just a sketch. I'm not going to be super picky whenever I grade these things, of course. But something kind of like this. Okay? And now, let's lock in our x-intercept. This is -16. Okay? And if you wanted to, you could graph that on the calculator, see how good it is or how well it looks, but that's good enough. Okay? Did this one in class. The second type of problem is finding the equation from the given graph. So I can see the graph here. It says find the equation of the graph polynomial. So first of all, I see 1, 2, 3 x-intercepts. If those are x-intercepts, So the general structure is going to be y equals, you're going to have some lead coefficient, and then you're going to have your x-intercepts, your factors. So this is going to be y equals some lead coefficient that I don't know yet, and then I'm going to have an x plus 2. I'm going to have an x minus 2. It's x minus the 0. And then this is 2, what is this? 1, 2, 3, this is a 4. Then I'm going to have an x minus a 4. However, I need to get the multiplicities down. This one must be a linear multiplicity, so it's a 1 power. This one, I guess it could be a 2 or a 4 or a 6, but it doesn't look especially flat and steep, so I'm going to say it's a 2. And then this one, again, it could be a 3 or a 4 because it flattens and crosses, or sorry, a 3 or a 5 or a 7, but it doesn't look especially flat and steep, so I'm going to just call it a 3. But I guess you could do a 4 or a 5 and maybe argue that that's what it is, but I don't think so. And I know this is a point on the curve. So your x-intercepts decide your factors. You use this point to plug in for x and y to solve for your a. So when y is 16, and when x is 0, x is 0, x is, x is 0, solve that for a. 16 equals, what is this here? This is 8 times 4 times a negative 4. So I'm going to divide by 8, and I'm going to divide by a negative 16. I don't want to take 16 times 8. That's a waste of time because I see a 16 over here. So those 16s are going to go away. So why multiply it out, right? Work smart, not hard. 16s cancel. So my a is equal to negative 1/8. So my final equation is y equals negative 1/8 x plus 2 to the third, x minus 2 to the second, x minus 4. If you graph that on your calculator and set the window to look like this window here, I think you're going to see that it looks exactly like that curve. Okay? 7.5 minutes. Oh, we can do another one. These are all kind of the same. In fact, I don't think there really needs to be 3 of them, but whatever. So this one is kind of unique in that it says find the equation of the 7th degree polynomial. So this one tells us it needs to be a 7th degree polynomial. Okay, well, it's going to be y equals a times, this is a negative 2x intercept, so the factor is going to be x plus 2. This is a 1 intercept, so x minus 1. Now those are the only 2x intercepts. If I just write it like this, this would be a 2nd degree polynomial. So we need to get a 7th degree. So I got to add some multiplicities to these. And of course, I need to add multiplicities. This one looks like it could be it's crossing and it's flat. So it could be a 3, 5, or a 7, or a 9. This one is flat, but it doesn't cross. So this could be a 2, 4, or 6. And these powers have to add up to a 7 because the multiplicities would make a 7th degree polynomial. So I guess I could call this a 2 and this a 5. That adds up to 7. Or I could call this a 4 and this a 3. That adds up to a 7. I think those are my only 2 possibilities, because if I try to get any bigger, I'm going to run out of room on the other. So 2 possibilities. This one looks flatter and steeper, and this one doesn't. So I think this looks like the 4th degree, and this looks like the 3rd degree. And to be honest, if this was a test question, I'd mark it wrong if you did the 2 and the 5, because it's definitely flatter and steeper. So put the multiplicity of 4 here, flatter and steeper. Put the multiplicity of 3 there. I still need to find my a value. Plug in the value 0.8. 8 equals a 2 to the 4th, negative 1 to the 3rd. 8 equals a times 16 times negative 1. Divide by negative 16, and I get my a value is negative 1/2. Y equals negative 1/2. X plus 2 to the 4th, x minus 1 to the 3rd. Good luck.